Go.
Okay, everybody take a look at this circle here.
Circle.
You have this in front of you, right?
Yes.
How many degrees are in a circle?
360.
360. So if you start here, this is 0 degrees. And all the way around is 360 degrees. So if we started here in standard position, this is the x-axis, and we rotated all the way around, you guys all know that this is 0 degrees or 360 from here all the way around, right?
Yep.
Well, what if we went halfway around the circle?
180.
180. What if we went a quarter or half of 180? So a quarter of 360 or half of 180 is 90. So each of these is 90 degrees, correct? So 90, if you added 90, what if you added 90 here? What do you get?
270.
And if you add 90, you're back at 360, right? Now, what if we took this 90, this little piece right here, and you cut it in half? This is a 45-degree angle. So each of these pieces is 45, right? So let's go around the circle and let's talk about what each of these angles is. Do you know what they are? So if this is 45, add 45, you get 90.
135.
Add 45, what do you get?
135.
135. Keep going.
230.
You get 180. Add 45.
225.
Add 45, 270. Add 45 to 270, what do you get?
315.
And add 45, you get 360. Now, what if I took this 90 degrees and cut it into 3 parts? So ignore
30,
this.
30.
What do you get here? 30.
Yeah.
So this is 30. And add 30, what do you get? 60. Add 30, you get 90. Let's keep going. We're going to add 30, and what do you get? 120. Add 30. 150. Add 30. 180. Add 30. 210. Add 30. Add 30. Add 30. And add 30. And finally, if you added 30, you get back to 360. So, you need to get familiar and comfortable with this circle.
360 always that side.
Yep.
It's always that
0 and
one.
360, yep. Now, when we measure angles, we measure them in standard position. Standard position means your initial side is on the x-axis, and we normally go, if we go counterclockwise, that and you get to your terminal side, if the arrow is going counterclockwise, that's a positive angle. If you're going the other direction, which is clockwise, that's a negative angle. Okay? So, look at this circle here. If I asked you to measure 45 degrees clockwise, it would be this angle right here. 45. This is 45 right there.
Would they be counterclockwise?
Are you going
You said
I mean
clockwise.
did I say clockwise?
Yeah.
Okay, I meant counterclockwise. A positive angle is counterclockwise. What if I asked you what angle this is right here?
Negative 45.
It is negative 45, or we can call it 315 degrees. So a negative 45 degree angle is going backwards. But if we were to go all the way around, we have 315 degrees. we say that these two angles are coterminal. When their terminal side lands in the same spot, they're coterminal. Now, does anyone know how to get a coterminal angle? If I went backwards 45 degrees,
You add 45 to 360.
yes, you are going to add
Same.
multiples of 360 in order to get coterminal angles. So, the first thing you're going to want to do, flip it over. I need to know, can everybody sketch each of these angles in standard position? Standard position is when you start on the x-axis, and I'm going to use this highlighter. So that's your initial side. Where would an 85-degree angle be?
Just right before that.
Yep. And I'm going to draw an arrow showing you the direction. This is 85 degrees. Okay, now 320. This is where I'll use coterminal. I don't want to figure out where negative 320 is. I don't want to go backwards. I like to go forward. So what I can do is, because I know now what coterminal is, if we add 360 to negative 320, what do you get?
40.
40. So guess what? I know where a 40-degree angle is, right? This is about a 40-degree angle. But that's not what I want. I just use that 40 to measure the angle. The angle that I want is negative 320. So it's actually this angle in orange. That is the answer. Because they're coterminal. A 40-degree angle is coterminal with a negative 320. Does that make sense? How about 180? That's easy. That is 180. Easy, right? Now, if I would have went the other way, I would have named that negative 180. So the direction that you're going, if you're going counterclockwise, it's a positive angle. And counterclockwise is a positive angle, clockwise is a negative angle. So could everybody right now, for me, sketch these graphs, these angles in standard position? 40 degrees, what does 40 degrees look like? That's 40. Negative 130. Now, you may want to do 360 and go the other way. What would 360 be if you went the other way?
230.
230. And where is your 230-degree angle? Well, we just did our circle. 230 would be just past 225, just a little bit. So it's going backwards, so it's going to be this angle right there. So negative 130 is going that way. How about negative 270? What's the answer? What angle is coterminal with negative 270?
90 degrees.
90 degrees. So a negative 270-degree angle is this angle right here. It starts here. It's coterminal. Its terminal side will be 90 degrees, but it's going this way. So this is negative 270 degrees. How about 120? It doesn't have to be exact. 120 and then 95. Make sure you have your arrow going in the right direction. Now, I talked to you about what coterminal means. Coterminal means that the terminal side will land on top of each other. If two angles are coterminal with each other, their terminal side will land right on top of each other. So they're giving you a 135-degree angle. A 135-degree angle is this angle right here. Well, if I were to go backwards, so in other words, subtract 360, I get negative 225 degrees. So if I go the other way, this angle becomes negative 225. So what we can say is 135 degrees is coterminal to negative 225. What that means is their terminal side will land right on top of each other. It's just that their direction might be off. Now what you can do also to get a coterminal angle, let's say I gave you 30-degree angle. This is a 30-degree angle. Another coterminal angle, if I rotated it around one more time, this and add 360 to this is 390 degrees. So 390 degrees, and I can add another 360 and get 750. A 750-degree angle is also coterminal to a 30. So I can keep adding or subtracting multiples of 360 degrees to find different coterminal angles. Does that make sense? So what is a coterminal angle? What is it?
They're the same terminal side.
Same terminal side, good. I want you to look at this got it 3, right here.
Got it.
Can you tell me, analyzing these angles, negative 315, 45 and 315 and 405, which ones are coterminal?
A and B.
A and B? Any other ones? And D. Now watch, I'm going to show you on my calculator because it's easier to do on the calculator. If you took negative 315 degrees and you added 360 degrees, what do you get? You get a 45-degree angle, which is that one. If I added another 360 to that answer, I get 405, so that's coterminal. This one is not coterminal. There's no way that a negative 315 and a positive 315 are coterminal. So these are coterminal with each other. That's the oddball. Okay, so let's practice these. I want to know the measure of an angle that's between 0 and 360. So it starts here and it goes this way. So 0 to 360. I'm going in that direction, 0 to 360. So now, here's my first angle, 385. What should I do with that to find a coterminal?
Subtract 360.
You want to subtract 360. Why did you figure to subtract 360?
You want to find the one between 360.
Yes, you're looking for the number between 0 and 360. So what do you get? 25. So a 25-degree angle is coterminal with the 385. How about the next one, 575? What should you do? Subtract 360, what do you get? A 215-degree angle. Is that between 0 and 360?
Sure.
It sure is. Okay. What do you do for 20? Negative 405.
720.
What do you do?
Add 720.
Well, let's first add 360. What do you get?
Negative 45.
Now, why did Nick say add 720? Because the first time around still does not give us an angle between 0 and 360. So what he did was he added two multiples of 360, which is 720. And what's the final answer? 315. 315 is the answer. How about the next one, 21? Add 360 to that. You get 4 degrees. Next one. Subtract 360, what do you get? 140. Add 360. 150. Subtract 360. 55. And add 360. Now, how would you show me the difference between a negative 180 degree and a 180 degree? What would you
The
do?
direction of the arrow.
The direction of the arrow. So, everybody understand that? That is a 180 degree angle. This is a negative 180 degree angle. Got it? So you have to have that arrow. Now, if you don't put this arrow here, look what it looks like. Oh, I'm so conditioned to do the arrow. So if you don't do that, it's not, there's no
Smile.
direction. You have to have an arrow, okay? It's very, very important. Are we good so far?
Yeah.
Okay, I have a question for you. What is the measure of this angle right here? 90 degrees. You guys know what that angle is?
Negative,
225.
225,
How'd you get that?
because if you, I don't know, you subtract 225 from 36. Wait, something like
I don't know,
that. I just know it.
Because first hour, I showed them something and they said that, they knew the answer without me showing it, and I wondered if you guys could figure it out without me showing. They said they didn't need me.
Well, we did.
Okay, so this is my little test here. Can you tell me what that answer is? And how'd you get that? By looking at the answer?
Oh, it says it right there.
Oh, hey,
Oh.
that's the thing.
I didn't even know.
We don't read very well.
I
Okay,
didn't see anything.
What about that answer? Do you know what that answer is?
That's two, wait,
225.
225.
How'd you get that?
There's a second.
It's 45 plus 180.
How did you know it's a 45?
Because it's 2 negative 2. That's, I don't know, it just makes sense when you look at it on the graph.
Okay, what about these ones? Would you be able to figure out what these angles are? Check these ones out right here.
Would I be able to figure that out?
Based on, and it has to do with geometry. So I'm pulling out prior information from geometry.
Oh.
By looking at those ordered pairs, do you know what angle you're talking about?
135.
Now, are you guessing at the angle based on the drawing, or are you using the numbers?
Well, it's okay, so it's 2 over 2, or it's they're both over 2, right? And I don't know, I can't explain it, but it's just like when you see it on, it's the same distance from each end, so you know they're equal parts. So it's half of that 90 in that quadrant, so it's 45 plus the 90, which is 135.
Okay, good. Can you do the other one though?
Which one?
Can you do these ones?
No.
Negative
See what I got to do?
320.
I got to throw in square roots and.
He makes your life hard.
So basically what you're telling me is you know what the angle is if these two x and y's are the same.
Yeah,
You know it's a 45.
yes.
Now, can I explain why?
Yes, please.
Is there anyone that doesn't know why? So there is some of you that do not know why it's 45.
Oh,
Okay,
yeah.
here is,
There you go.
actually, let me go. Do you guys know what the unit circle is? Okay, if I gave you this circle here with a radius of 3,
Okay.
that is a circle with a radius of 3. If I gave you a circle with a radius of 2, that's what it is. And if I gave you a circle with a radius of 1,
It's a bullseye.
you know what that is right there? That's a unit circle. Now what I can do, see this circle? I can cut it from here to here is 90 degrees and 180 and 270. I can do this, I can cut that in half, right? And I can draw a right triangle. Can you guys even see what I'm doing?
Yeah. So if we did it,
You
the
can?
other ones would be the same.
You can see that?
Yeah.
Wow, you guys have good.
Well, can
good
you
vision.
see it?
No, that's why I did this. Made it bigger for you. I thought
Oh.
you guys would see it. I don't see it.
I'm
So
blind.
I took this
Can we feel
unit
it?
circle right here and I blew it up for you. because I love you guys.
Love you too.
Okay. So, this is that unit circle. Let's talk about what is, and I know you guys, you understand it better when it's on a coordinate plane. What is this ordered pair right here where my pencil is?
One more.
1,
Oh.
0.
Oh, I thought you were talking
What's,
about
what's, let's go back to the center. What's that ordered pair? 0, 0. What's this ordered pair right here?
1, 0.
1, 0. What's this one?
0, 1.
What's this one?
Negative 1.
Negative 1, 0. What's this one?
0, negative 1.
It's spinning me for a loop.
It's because they're all
You guys
1.
okay?
They're all some form of 1 and 0. So
Okay, so here we are back on this circle here. This is your origin, 0, 0. This ordered pair is 1, 0.
Wait, I'm good at this part.
And this is 0, 1, right? Do you all agree that this is a 90-degree angle right here?
Jeez.
So if I cut this in half, what if we say this is from here to here? How many units is it from here to here?
1.
1. So if I cut this in half right here, what angle is it? And I drop a line right here. What angle is this?
45.
This is a 45-degree angle. What is this angle right here? 45. You learned in geometry. 45, 45, 90. Now, this is a 1, so that hypotenuse is a 1. What did you learn in geometry? That if you have two 45-degree angles, it's an isosceles triangle. So, check this out right here. What is the length? If the hypotenuse is 1, what is the length of these two sides? Do you guys even know?
Square root. It's 1 square root 2, something like that.
Is the square root?
There's rules. There are rules.
Okay,
for
you're
going from
guessing,
the
so
law.
I'm gonna prove it to you. If you take these
No,
two
it's
legs
not.
and square them and add them together, you get the hypotenuse squared, right? Now, what is this? 2x squared equals 1, divide by 2, and then take the square root of each side. So x is the square root of 1 over the square root of 2. Well, the square root of 1 is 1 over root 2. So these two sides are
I was
1
right.
over root 2. You were guessing. You guys were guessing and you were close. Now, I don't like this triangle with radicals in the bottom. Can I multiply all three sides by something? Square root of 2. If you multiply this by square root of 2, this by square root of 2, and this by square root of 2, you can do that. Your new triangle is what? 1, 1, root 2. So, if you have a 45-degree triangle, 45, 45, 90, these two sides will be the same, and then that's going to be the square root of 2 times whatever that is.
They're 30, 60, 92. Don't do that. Oh.
This makes me.
Gotta go back to Miss Young's now.
So now,
I thought this was easier.
let's pull, look at this problem right here. See this point, -2, -2? This is what it is. It's going over 2 units this way and down to right here. So they give you this point. So it's 2 this way and 2 this way. What does that tell you if these two are the same? What does it tell you that this little angle is right here? It's 45 degrees. So now if I asked you to measure from here to here, what's that angle? 180, and then what's this? 45. So what's 180 plus 45?
225.
So this is a 225-degree angle. Same with the one here, even though it says it gave you the answer. This is giving you, this is a 45-degree angle right here. Over 2, down 2. This is 45, which means this is 45. And this from here to here is 90. 90 plus 45 is 135.
Negative 135.
Get it?
Yeah.
Do you get it? Okay, so let's do a few of these here. What's this angle right here?
Did you change my absence?
No, I will.
Okay,
Thank you.
thank you.
Thank you for reminding me. Okay, number 7. Number 7. So, if you construct this side is 2 units and this side is 2 units. So what angle is this? It's a 45-degree angle. From here to here is 45, but that's not the measure I want. I want from here to here. So how would you figure that out? Negative what? So do 45 minus 360, because we're dealing with coterminal, and what's your answer? Negative 315. Do you get that?
Yeah.
Yes or no? Okay, check the next one out. Okay, how do you get to this point? Negative 5, negative 5. You went 5 this way and 5 that way. These two legs are the same, so what's this angle right here? 45. So what does it measure from here to here?
-135.
Negative 135. Excellent. Okay? Now, we have to move on to this triangle right here.
We could not.
Okay, now I'm going to take this little, very difficult to read triangle here instead. This is the unit circle. Instead of cutting this half, I'm going to cut it into 30 degrees right here. So again, this is still, because this was 0, 1, this is 1, this is 30. What's this angle right here? 60. This is stuff you guys learned in geometry. So we have a 30, 60, 90 degree triangle. Now, you learned in geometry that the side opposite the 30 degrees is half of the hypotenuse. So if we say that this is 1 and this is a half, how will we figure out what this side is? Well, back to the Pythagorean theorem. Let's see what we get. X squared, does anyone have a guess? What?
1/4.
See if they remember what it is.
Something √3.
Subtract 1/4. Square root of both sides. So what's x? √3 over 2. This is going to be √3 over 2. Now I don't like this triangle, how it's labeled. So this is what we have. We have 1, a half, and √3 over 2. Can I make these numbers easier?
Multiply them by 2.
You can multiply them by 2. And what would you get?
2, 1, and
You would get 2, 1, and √3. This is the triangle that we usually know. The side opposite, I want you to, you should know this. Now, Alexa, you just made a face, so tell me why.
No.
You multiplied these all by 2, right here.
all of it.
All of it. 2 times 1 is 2. These two cancel, you get 1. These two cancel, you get √3. So the side, you should know this, you guys. The side opposite the 1 is 30. The side opposite the √30 is 60. So we'll go across, and this is a 60 degree. Now, if you want to remember it this way, the side opposite the 1/2 is 30. The side opposite the √3 over 2 is the 60. Another thing you can remember is the shorter side is the 30, and the longer side is the 60. Does that help you?
If you think if you drew it different, they look really close on the one you drew.
Looks like the 30 and the 60 should be flipped.
Yeah, like the triangle that you just drew.
Oh, because I didn't draw it to
looks-
scale? Okay, yep. Well, look at number 9. Look at number 9. They give you -1, -√3. How would you, here's your triangle right here. So from here to here is -1 unit. Now, I don't care if you call it 1 or -1. It's really -1 from here to here. And from here to here is -√3. So now, what triangle is this? It's this right here. It's this one. So can you have to break that triangle apart. That's what you have. It's twisted around. So where do you get the 1 at? This is the 1, so what angle is this right here? This is going to be your 30 degree. This one opposite the √3 is gonna be your 60. So this is 60 right here. Sorry, it's hard to. So this is your 60 degree. So in other words, your triangle is drawn like this. Drawing it bigger. So this is your 1, this is your root 3. So this is gonna be 60, and this is gonna be 30. Does that make sense? The side opposite the 1 is your 30. So now, according to my question, they want to know, how big is this angle right here? So what are you going to do? How are you going to figure out from here to here? If this piece right here is 60, what are you going to do with that
Plus
and
180,
that?
240.
180 plus 60 is 240. So this is a 240 degree angle. How about number 10?
150.
Now, how'd you do that?
Well, okay, so you know the 90-degree angle on the right side. This one looks like a little more than half of it, and you know it's not the full 90 because it's not at the end, so you can just assume that it's 60.
Well, this is 1/2.
Uh-huh.
I'm sorry. Back, sorry. This is negative root 3 over 2,
Oh, actually.
and this is 1/2. If you multiply these sides by 2, what triangle is this? I'm drawing this triangle right here. This would be root 3, and this would be 1. So what angle is this right here then? That's the 30. So what angle is this then from here to here? You ready?
60.
No.
No? No, from
150.
here to here.
It's
This
150.
is 30,
Oh.
it's 150, good. Nick, explain.
Okay, so you just drew that 30 and the triangle to the other side, right?
Mm-hmm. This
So-
is the 30 right here.
Wait, can I like show you something?
Mhm.
Sorry. I don't know, it's just how I thought of it.
Oh,
They're like,
Jesus.
No, I just thought of it like if you think that you the line,
Yeah,
right? Because that's all that is. There.
yeah.
So if this is 180, subtract the 30 from 180, and that's 150. That's a
Yeah,
linear
same,
error.
yep, yep. Did everyone
Sorry,
understand
you
that?
guys were looking confusing.
I did.
This is a straight, he's saying that this is 180 degrees. If you pop out 30 degrees, because we figured this to be 30, 180 minus 30 is 150.
It's yours?
How about the next one?
This isn't yours.
So I need you to name from here to here.
330.
This is 2 root 3, and this is negative 2. If you divided these sides by 2, by 2, by 2, you know by 2?
Do you divide by 2 every time?
You do whatever it tells you. You get that. Now, do you know what's what?
Oh, no.
This is your 30. The side opposite the 1 is 30. And then this would be 60. So this is 30 right here. Let me draw it bigger for you. Okay, so what they did, they gave you the ordered pair, 2 root 3, and then down 2. That's this ordered pair. This ordered pair, you start at the origin and you go 2 root 3 over and down 2. Whoops, 2, not comma. 2 root 3, comma, negative 2. So this is the x value and that's the y value. Now, I don't like these numbers, so I'm going to divide them both by 2. And you get, this side would be root 3, so here's your triangle now. This is root 3 and this is negative 1. So this is a 30-degree angle right here, because it's opposite the 1. The angle opposite the root 3 is the 60. There's your 90. So now, can you tell me, if that's a 30 degree, I'm asking you, how big is this angle going backwards? So you're gonna do 360 minus, actually, you don't even have to do minus, you can just do negative 30. It's negative 30 degrees going backwards. Does that make sense?
Yep.
Okay, and then this one right here, you're gonna draw a triangle here. So this side is 3, and this side, and I'm gonna, do you get it? So you have, here's your triangle, make it bigger. You have, this side is 3, and this is negative 3 root 3. What should I divide these by? 3. So when you ask me, do you always divide by 2? No, this one I'm dividing by 3. So this, think of this as 1, and this is what? Root 3. So this now is 60 degrees. This is 30 degrees. Does that make sense? So now, what is this angle from here to here? Well, if this piece is 60, how do you measure from here to here? I would do 360 minus 60. And I get a 300 degree angle. Does that make sense, guys? Do you think you understand it?
Yeah.
Okay, now, did you guys do any trig stuff in geometry, sine, cosine, and tangent?
Yeah,
Unfortunately.
but not on circles.
Not on circles?
We did for triangles.
Yeah.
Okay, well, you put the triangle inside the circle. Just like we just did here. Okay, do you remember what, do you guys remember what sine is?
I don't know.
Yeah.
So
Yeah.
Katoa, opposite over hypotenuse.
Let's write this down. Let's go take a little walk on memory lane.
So Katoa.
Okay, if we were talking about this angle right here,
Yeah.
this is the adjacent side, this is the side opposite, and this, the side opposite the, I can't write that.
A Harry Potter.
Okay, so what does sine mean? It's a ratio, and it's the side opposite over the hypotenuse. What is the cosine? Cosine is adjacent
Over hypotenuse.
over hypotenuse, and what's tangent?
Toa, opposite over adjacent.
So you're telling me you learned this before?
Yeah.
Right.
SOHCAHTOA, S-O-A, so
No, S-O-H.
Toa. S-O-H, so,
C-H-T-O-A.
ka, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so now, back to this unit circle right here. Everyone remember that this is 1, 0, this is 0, 1, this is negative 1, 0, negative 0, negative 1, and you should also know the angle measures. This is 0 degrees, this is 90, 180, 270, 360, right? Now, if we draw a triangle inside here, like a 45er, okay, they actually did a 30 right here, let's do a 45. Because you guys seem to understand 45 is the best. So if I made a 45 degree angle here, can you name the sides for me? 1, 1, root 2.
Yeah.
So if I said, what's the sine of a 45 degree angle? Well, sine is opposite over hypotenuse, so this would be 1 over root 2. What if I said, what's the cosine of 45-degree angle? And you'd say adjacent over hypotenuse. And what's the tangent of a 45? It'd be 1 over 1. Well, what if I took a 30-degree angle, which we just talked about a second ago? Here's your 30. Can you name the sides of 30, 60, 90? Yes. 30, opposite the 30 was the 1. This was 2, and this was root 3. So if I ask you, what is the sine of a 30-degree angle? It is 1/2. If I say, what's the cosine of 30? It'd be root 3 over 2. And if I say, what's the tangent of 30? It's 1 over root 3. If I say, what's the sine of a 60-degree angle? 60, sine of 60 is opposite over hypotenuse, so root 3 over 2. If I say, what's the cosine of 60? Cosine is adjacent over hypotenuse, 1/2. And what's the tangent of 60? It'd be root 3 over 1. Did you guys ever do that?
Yes.
You did?
Yes.
Okay, now the other thing you need to know, that on your unit circle, what point is this right here?
1, 1,
1, 0.
0.
So,
Now, if I drew a 30-degree angle here and named a point here, this would be X and that would be Y, right? Okay, I'm going to call this X and this Y. Instead of saying the sine is opposite over hypotenuse, you can say it's the Y value over the R value. This is your radius. So instead of thinking of sine, sine is the Y value over the R value. It's opposite over hypotenuse. Think of sine as Y over R. So now I'm going to give you 3 new definitions. Sine, instead of saying opposite over hypotenuse, it's the Y value over the R value. Cosine is the X value adjacent over the R values. Anyone know what tangent is?
X
It's
over Y.
opposite over adjacent, which is Y over X. So, check, go back. Tangent is Y over X. Okay, so now look at these right here. They're just doing sine and cosine. They're not even doing tangent on these ones. Here is a 90-degree angle from here to here. So instead of saying what's the sine of 90 degrees, sine is defined as Y over R. And on this unit circle, R is always 1. The radius is 1. So at 90 degrees, here's 90 degrees right here. Here to here is 90 degrees. This ordered pair is 0, 1. What is the Y value at 90 degrees? What's that Y value? 1. What's the R value I told you?
So it's 1.
1. So what's the sine of 90? It's 1. What's the cosine? Cosine, we said, is X over R. Well, what's the X value at that spot?
0.
0. What's 0 over 1?
0.
0. Okay, now here's another one, negative 180. Here's negative 180 degrees. We are at the X value, negative 1, and the Y value, 0. So what's the sine? What's the sine of negative 180? Well, sine is Y over
0.
R. Well, what's the Y value?
0.
0 over 1 is 0. And cosine is X over R, so it's negative 1 over 1, which is negative 1. Here's 270. From here to here is 270. This ordered pair is 0, negative 1. The sine is X over R, so 0 over 1 is 0. And the sine is Y over R, negative 1 over 0. I'm sorry, negative 1 over 1, which is negative 1. Okay, now, I want you to do this. Got it? A. What's the cosine and sine for negative 90 degrees? Well, where's negative 90 degrees?
So, 1 127.
It's right here. What ordered pair is that? 0, -1. So this is 90 degrees. -90. So what's the sine of -90? What's the definition of sine? What's the definition of cosine?
X over.
This is y over r and this is x over r. Well, what is the y value here?
1, -1.
-1 over 1 is -1, so that answers -1. What's the cosine? 0 over 1, which is 0. You get this? How about 360?
1 and 0.
Try to find a spot. Where is 360 degrees, everybody? It's right here. This is 360 degrees. What ordered pair is this?
1, 0.
1, 0. What's the sine of 360 degrees? Well, sine is the y value over the r value. What's the y value here? So 0 over 1 is 0. What's the cosine of 360? Well, cosine is x over r. So it's 1 over 1, which is 1. In the last one, they give you a 540 degree angle. Where the heck is 540 degrees?
120.
Let's subtract 360. What do you get?
180.
180. Where's 180? It's right here. -1, 0. So what's the sine of 540 degrees? It's the same as the sine of 180. And sine is y over r. Where's the y value? 0. 0 over 1 is 0. And what's the cosine going to be? It's x over r.
-1.
So it'd be -1. Okay? I want you to try this back page for homework and see if you can find the sine and cosine of these three problems right here.